Hello everyone, welcome back to the interviews problem series. In this video lecture, we shall solve this problem longest common substring. So we're given two strings x and y. We have to find the longest common substring of the two strings. Fine. So the input contains two lines. Each line contains a string, and the string consists of characters from small a to small z. And in the output, we have to print the longest common substring. Fine. So the constraints of the problems are the length of the strings goes up to 10 to the power 4. Okay, let's see an example. A B C D A B D E F. Okay, so in these examples, in these strings, the longest common substring is AB. Okay, so this is the longest common substring, and that's the answer here. Fine. So let's see how we can solve this problem. Okay, so the naive approach, one of the naive approaches to solve this problem is to generate all the substrings of one of the strings. So that means either take x or y and generate all the substrings of that string, and for each substring try to check if that substring exists in y or not. Okay, for instance, we have for this, let's say we generate all substrings of the string x. So there will be n substrings of length 1. There will be n minus 1 substrings of length 2, because 1, 2, 3, 4, and the length of the string is 5. Okay, and there will be n minus 2. Here n is the length of this string. Okay, n minus 2 substrings will be of length 3, and so on up until 1, which is the substrings of length. One is the substring of length n. Okay, and this will give me n into n plus 1 by 2. So these are the number of substrings this string has, and for all these substrings we'll check if they exist in y or not. This can be done using some standard pattern search algorithm, say KMP algorithm, in big of m time complexity, where m is the length of the string y. Okay, so for all the substrings that we have generated, we take those substrings which are present in this string y, and they are of greatest length. Okay, and any of those strings will be our LCS for this set of strings. Fine. To generate all the substrings, to generate all n square substrings of this string x, we would require we would require an algorithm of n cube. Okay, how? So let's say I run a for loop for let's say, so this, I take a pointer I, so I run a loop from 0 to n minus 1. Okay, and another loop which moves from j, so j moves from I to n minus 1. I represents the starting index of the substring, j represents the ending index of the substring, and we generate inside these loops. So this is outer loop, this is a nested loop. Inside that I use another loop to generate the substring as from I to j. So this will cost me a time complexity of n cube. Fine. So because this will be of length n in the worst case, where I is 0 and j is n minus 1. Okay, so that's the case. So the overall time complexity for this method is n cube, which is used for generating substrings, and for each substring we check using KMP. So this is the time complexity, n cube into m, which is a bad time complexity and will not work for these constraints, okay, as it is clear. For instance, for a string of length 10,000, or let's not take 10,000, even 1,000, the, the time complexity will be 1,000 raised to the power 3 into 1,000, okay, and this will give me 10 to the power 12 time complexity, and the time taken will be 10 raised to the power 4, which is huge, and this will give me DLE. So this algorithm is not going to work for this problem. Fine. So we have to devise another optimal algorithm. Okay. So this was not a brute force approach. This is one of the naive approaches. The brute force approach is the one which has the worst time complexity, and it is the simplest approach. So this is the brute force approach that I'm going to discuss right now. So imagine a function LCS ij. This gives me the longest common substring of the strings from 0 to I and string y from 0 to j. Okay, so this function will return me the answer for these two strings, namely the LCS of these two strings, if I call them on the last indices 4 4, because 0 1 2 3 4. Okay, now how will this function work? How will be the body of this function? So this function, basically what it does, it starts from the characters which I am passing. So ith character of the string x, jth character of the string y, and it check if these characters match or not. Okay, so in this case they are not matching, but imagine that if the characters match. Here I have a instead of f, I have a here. In that case the characters are matching. Initially the length of the substring I will put as 0. So when I'm calling this function, the length of the LCS is 0, but since I find a matching character, the length, whatever the length is, it will increment by 1, and I will call the same function on these substrings a b c d, a b d e, because I have already found the last character of the LCS, which is a, because it is matching. Fine. So this is one of the cases where last character is matching, but this is not the only case, because it may happen that the substring, the longest common substring, may exist in this this string and this string, okay, or on this string and this entire string. In that case, how would I solve this problem? Okay, so that's why first I check if the last characters match. I call the function LCS for the previous indices, namely the left indices of okay, I will move the pointers I and j to the left by 1 if the characters matches. If they do not match, then I call the function on in on the previous index of a string x and on the previous index of the string y. Okay, so it is 4 and 3. Okay, so I check if the LCS exists in this and this string, or in this entire string and taking this string. Okay, and third case is checking in this and this. In third case, the length of the final string will be +1. So whatever the length this function, the function for this substring will return, I'll add 1 to that answer because the last characters are matching. Fine. So let's see how this function will look like if I implement it. So this is the function, this is the base case. Okay, the base case is if I exhaust one of the strings, namely if I exhaust x or I exhaust y, then there's no meaning in comparing the remaining string with the empty string. So whatever the answer I have, I will return that. Otherwise, if the characters ith character and jth character, ith character of x and jth character of y, if they match, then I move my pointer I and pointer j to the left by 1. Okay, and increment my length by 1 because the last characters are matching. Although they are not matching here, but in case they are matching, I'll increment the length by 1. Fine. So that's the case I covered here. Then I cover other two cases where I compare the substrings, the LCS in this substring and this string and this string and this entire string. So these are the two corresponding cases for those scenarios. Fine. And I take maximum of all the three cases. That will give me the LCS for the strings x and y. Okay, and finally I return my count. So that's how this LCS function is working. So these are the three major cases which I have to cover. Let's see how we can let's analyze the time complexity of this solution. Let's see the time complexity of the solution which I discussed in the previous slide, namely the recursive solution for the LCS problem. I call the function, so these are the input strings x and y. I call the function at these indices 5 and 5, and the initial length of the LCS is 0. Here I'm passing the length as a third variable in the function, and since the last characters are not matching, so I call the function for this string and this entire string. So I move my pointer I, which is here, to the left by 1 and it becomes 4. And another case which I'm covering here is moving the pointer j by 1 to the left and then calling the function for calling the LCS function. Okay, and the length will be 0 because the characters, the ith character of x and jth character of y are not matching. I repeat the same procedure for these strings. Okay, and so on. Fine. So this the let's see how the what is the time complexity of this solution. So you can observe that at each level, each function is calling two functions, or we can say the branching factor of a function is 2, and the height of the tree will be say min of n and m, where n and m are lengths of these input strings. Why? Because once I exhaust one of the strings, there is no meaning in comparing the remaining string with the empty string. Fine. So that's why this will be the height of this tree. That will give me a time complexity of 2 raised to the power min of n and m. Okay, so this time complexity is also not that good. It will not work for the given constraints 10 to the power 4 and 10 to the power 4, because in the worst case scenario 2 raised to the power 10,000 is a huge number. Okay, So this is a solution which is not which cannot be used to solve this problem. Okay, so we have to improve upon it, and we know that the improvement over a recursive solution is memoization. So how this will work, let's see. So you can see that observe that the functions here LCS34, the computations are performed again and again. Here LCS34 is again called, here it is again called. So I'm performing these computations 3 times. Okay, rather what I can do is I perform the calculations once and then I store the result in this TP in an array. Okay, since we have two variables which are changing at each level, namely the index I and j, so I prefer to use a 2D memoization table or DP array, where dpij represents the longest common substring for the strings from index 0 to I, it's I here, and from index 0 to j. Okay, so if for this LCS34, once I compute this result, I will store this result in dp34 here, like this. So after I store this result in at this location of the array, once I encounter the same function call, I do not have to perform the computations again. Rather, I return the result which I already have in this array. Fine. So let's see the memoized code. Okay, so this is the memoized code for the LCS problem. So this is a DP array of dimensions m cross n, a result initialized to 0, and here I am running my loop which runs from 0 to m. M is the length of string x and n is the length of string y. So this is a nested loop, and this is the base case which I explained here, namely if I exhaust one of the strings, then the answer for that LCS will be 0, because the LCS for an empty string and a non-empty string will always be 0. So for the row 0, the LCS for all other columns will be 0, and for column number 0, the LCS for all the rows will be 0. So this is 0. Okay, so this is the base case. And if ith character and jth characters match, for instance, if let's say here we have a, if this character matches with this character, then all I have to do is find the LCS for these two strings. Okay, that will be already computed in dpi minus 1 if this is I here and this is j here. Okay, then the result for these strings, for these substrings, will be already present in dpi minus 1 d and j minus 1. Okay, and I will increment this by 1 and store it for the substrings I j, 0 to I and 0 to j. Okay, here, and I will update my result variable with the current maximum dpij, that is whatever the result we have, I update it with the newly updated dp array here. Fine, otherwise if the characters do not match, then the LCS for the substrings, for these substrings, will be 0 here. Okay, and finally I return the result. This will give me the longest common substring of these two strings. Fine, so let's see. So once I have the length, so this is just the length of the LCS, how would I generate the string, the actual LCS? Okay, so let's see how we can generate the actual substring, the longest common substring, given that we have already calculated the length of it. So this is the function to generate that. Row, it takes in the argument the string x. We can take y as well, but because LCS is present in both the strings, row and column represents the row and column number of this matrix where we have found our LCS, or longest common substring length. Fine, so they are extracted from this at this point. So whenever the result is updated, we update our row and column variables. Fine, so let's see how we can solve this problem, how we can generate the LCS. So we declare a result array. Okay, so this result array has a size of len, and I run my while loop. This while loop starts this while loop run uh, len times. Okay, this while loop run len times, and it stores the characters at the it stores the LCS. It stores the longest common string in the resultant array. So initially row, we have row to be 2. Okay, because this is the index, this is the row number where we have found the LCS length, and column is also 2 here. Okay, and initially we append the character at row -1, so that is here b. So we append b to the resultant. Okay, so this is the resultant string, it is of length 2, and we move our len to 0 to 1. Okay, so this is, then we move the row and column to this position. So I backtrack to this position. Okay, so and then we put the character a into our resultant string and move our row and column to this position. Here I backtrack to this position. Fine, and here it is 0. Then I exit this loop, and I return the result that I have obtained. Fine, sorry for my bad handwriting. So that's how I extract my target string, or the longest common substring, using the generate function given the length of the string which we have already computed from this code. Let's see the time complexity for this problem, time and space complexity for this solution. So you can notice that I'm using a nested loop here. The outer loop runs m times, the loop inside runs n times, so the time complexity is m cross n. Okay, and the time complexity is m cross n. So this will work fine for these constraints, because 10 raised to the power 4 into 10 raised to the power 4 will be 10 raised to the power 8 in the worst case, which will work approximately in 1 second, and this is the time limit for most of the judges. And the space complexity will obviously be m cross n, because I am using dp array here of the dimensions m cross n. So that's the time and space complexity. There is another solution for this problem, which is space optimized. So that will take a space of big of n only, that we will discuss in the next video. So thank you so much for your patience, and stay tuned for more such videos. I have attached the code for the solution in the description. Okay, so this is the code in C++. Okay, so this is the implementation in Java, and this is the implementation in Python language. Okay, I have attached the codes in the description, so make sure